Hello and welcome. In this video we want to learn the tabular integration method for finding the integrals. Tabular integration method is a method that we can use it instead of the integration by part method. The reason that we prefer the tabular method is that this method is quicker than the integration by parts method. We will learn this method in this video and the next videos. One case that the tabular method works very well is when we have integrals in this form. A polynomial, by polynomial I mean things like this: x to the 2, 2x minus 5, x to the 3, plus 2x, and so on. Any polynomial times by trig functions and exponential functions times by dx. By trig functions I mean something like sine x, cosine 2x, and exponential functions like e to the x, 2 to the x, 3 to the x. So if we have integral in the form of any of these functions times by any of these or these, we can find these type of integrals with the tabular method. Let me show you an example that can help you to learn this method. Let's say we want to find integral of x to the 2 times by e to the x dx. X to the 2 is a polynomial, e to the x is exponential, so we can use the tabular method for finding this integral. In the tabular method, always we make a table for finding the integral. This table has 3 columns. Sign, by sign I mean plus, minus, plus, minus. And this column is always the same. It doesn't change. In all the integrals, you have this column, and always in this column, we have first a plus, then a minus, then a plus, a minus, and so on. This continues forever. The 2 other columns are a derivative column, so D means derivative, and one integral column. In the derivative column, you have to put the polynomial part of your integral. So in this example, x to the 2 goes to the derivative column, and e to the x goes in the integral column. So the polynomial goes always to the derivative column, and the exponential, which in this case is e to the x, or the trig function, goes in the integral column. Now you have to fill these rows. How we can find the next row and the next row and so on? You have to take the derivative of x to the 2, and then take the derivative of that, and continue till you get 0. Derivative of x to the 2 is 2x. Derivative of 2x is 2, and derivative of 2 is 0. Because in this column always we have a polynomial, so finally by taking derivative again and again, we get to 0. Now for the integral column, you have to take integral. What is integral of e to the x? E to the x. What is integral of e to the x again? E to the x. And you have to continue this up to the row that is 0. And finally, integral of e to the x again is e to the x. So let's review the process. Always you have this column, which is a plus, minus, plus. And always, don't forget, it starts with plus, then minus, plus, and minus. The polynomial goes inside the derivative column, and the exponential or trig goes inside the integral column. You have to take derivative of the polynomial to get to finally 0. You have to repeatedly take the derivative to get to 0. And then you have to find the integral of exponential or trig function. And almost you are done. Maybe at first it seems that it needs a lot of calculation. But attention, for finding this integral with the old style, with the integration by parts method, you need to do integration by parts twice. You have to use this formula, integral of u dv equals uv minus integral of v du, twice. And it needs a lot of calculations. You have to choose u, dv, and do du, take integral, and so on. It needs lots of calculations. But if you get familiar with this method, you can find the integrals much faster. Now, finally, what is the answer of this integral? The answer of this integral, you can find it this way. Always, you start with the first element in the first row, from here. You have to multiply it by the second element. Then you multiply the second element in the third element. Multiply the third element in the fourth element. But don't forget, you have to attach these signs to the first, second, and the third element. So, what would be the answer? The answer of this integral is x to the 2, attention, plus x to the 2 times by e to the x. So, x to the 2 times e to the x. For the next element 2x, this negative attaches to the 2x. So negative 2x times e to the x. So this multiplies by this 2x e to the x. But negative, don't forget this negative. And this negative, let me explain where it comes from. Do you remember this formula? This negative is because of that formula. Basically, the tabular method is based on the integration by parts, but it's faster than the integration by parts. And finally, the last element is plus 2 times e to the x. So the answer is plus 2 e to the x plus c. So the integral of x to e to the x is x to e to the x minus 2x e to the x plus 2e to the x plus c. Let me show you another example. Here we want to find integral of x2 minus 2 times cosine x dx. Immediately we make our table. The sign goes here, then derivative integral x2 minus 2 goes here, the cosine x goes here, and don't forget plus, minus, and so on. Derivative of x2 minus 2 is 2x, derivative of 2x is 2, derivative of 2 is 0. Integral of cosine of x is sine of x, integral of sine is negative cosine x, and the integral of negative cosine x is negative sine x. So, try to write the answer of this integral by yourself. Don't forget, you have to multiply the first element in the second in the third in the fourth, and so on, by considering these plus, minus, plus, and so on. So what would be the answer of this integral? It's a good idea to pause the video right now, try to write the answer, and then continue watching the video. The answer would be x2 minus 2 times by sine x, then minus 2x times negative cosine x, and finally plus 2 times negative sine x plus c. Again, if you want to find this integral with the integration by parts method, you have to use the integration by parts method twice, and it takes much more time. Attention, if you want, you can simplify this answer, but I'm leaving it in this form. Let me show you another example. We want to find integral of x to the 2 times by 3 to the x dx. X to the 2 is a polynomial, 3 to the x is exponential function. We make a table, the sign, derivative, and integral. x2 goes here, 3 to the x here, and plus, minus here. Derivative of x2 is 2x, derivative of 2x is 2, derivative of 2 is 0. Maybe you forgot the integral of 3 to the x. Let me remind you, integral of a to the x dx in general is a to the x over ln of a. This is a formula that we have for integration of exponential functions. Integral of 3 to the x based on that formula is 3 to the x over ln of 3. but we have to integrate this again. And what is integral of 3 to the x over ln of 3? It would be 3 to the x over ln of 3 to the 2. Because you have to take the integral of 3 to the x again. And integral of 3 to the x is again 3 to the x over ln of 3. And we have one ln of 3 already in the bottom, so it becomes ln of 3 to the 2. And can you guess what is the integral of 3 to the x over ln of 3 to the 2? It would be 3 to the x over ln of 3 to the power of 3. So, based on this table, now definitely you know what is the answer. The answer would be x2 3 to the x over ln of 3 minus 2x 3 to the x over ln of 3 to the 2, and finally plus 2 times 3 to the x over ln of 3 to the 3 plus c. Let's do one more example. T to the 2 sine of 3t dt. As usual, we make the table, the sine column, the derivative column, integral column, plus minus. In the derivative column, we put t2, then 2t, 2, and 0. The sine, the 3 goes here. What is integral of sine? If you remember, integral of sine is negative cosine. But we have sine of 3t. And because of that 3, the integral of sine of 3t would be negative 1/3 cosine of 3t. The reciprocal of this number goes here. You should be familiar with these type of simple integrals. What is integral of cosine of 3t? 1/3 sine of 3t. And 1/3 we have here, so negative 1 over 9 sine of 90. And finally, if we integrate this again, we have 1 over 27 cosine of, why I wrote 9 here, it's 3t. So finally, what is the answer of this integral? Multiply the first in the second in the third the fourth, and don't forget the plus minus plus. So what is the answer of this integral? It equals to negative 1/3 t to the 2 cosine 3t. Minus and minus cancel each other, so it becomes plus 2 over 9t sine 3t. And finally we have plus 2 times 1 over 27, so 2 over 27 cosine 3t plus c. And this is the answer of this integral. If you want to learn more about the tabular integration method, you can watch the next videos about this method. I hope you like this video. If you like this video, please subscribe in my channel and see you in the next videos.